Hello ladies and gentlemen, welcome today to our lesson. Today we're going to be learning about some polynomial long division. But before we start our polynomial long division, I'd like to do a quick recap on just normal long division. So say we have 363 divided by 3. On a normal day, I would probably tell you to just throw this in your phone or do it in your head. You could probably do it pretty easy. But we're going to go through this. We're going to go through our 4 steps of long division so that you guys can see and remember how to do this. So our first step that we want to do, and I'll write them up here. Our first step that we want to do is look at our first digit and divide it by our divisor. So divisor, dividend. So what we are dividing is our dividend, and what we are dividing by is our divisor. So we look at the first digit of our dividend, and we're looking at our divisor, and we're going to divide these two guys. So if we take our 3 from our dividend and divide it by our 3 from our divisor, we get 3 divided by 3, which gives us 1. So that's our first step, division. The next thing we want to do, once we've gotten this answer from our division 1, we want to put it on top of our long division sign. Also, just a quick reminder, we put our dividend, our long division sign, and then our divisor. So 363 divided by 3, 363 divided by 3. So now that we have this 1 on top, we've done our division, we want to multiply. So we want to multiply this 1 by our 3 out here, or whatever this divisor is. It could be 4 or 5, whatever it is, but in this case it's a 3. So hopefully we know that 1 times 3 is 3. Once we get that 3 from our multiplication, we're going to put it down here and we're going to subtract it from our dividend. So that's our next step, subtraction. So we know that 3 minus 3 is 0, so you can either cross it out, you can put a 0, you can do whatever you like. I personally like to put the 0, it's just easier for me. So then our last step that we want to do, using a down arrow to signify it, we want to drop down whatever's left over. So in this case we have a 6 and a 3 left over, our other 2 digits. We want to drop that down to here. So now that we've done that, these are our 4 steps: divide, multiply, subtract, bring down. Once we've done those 4 steps, we just want to do them again, only now, since our 3 is gone, we're going to look at our 6. We're going to look at the next digit in our dividend. So we look at our 6 and we're going to divide it by 3. So if we go over here, 6 divided by 3, hopefully know that that's 2. We're going to put that on top. So we've done our division for this round, and now we want to do our multiplication. So I'm going to go multiply. 2 times 3, we know, is 6, which is good because we want to actually eliminate one digit at a time. So like we eliminated this 3, now we want to eliminate the 6, which is down here, and then we'll want to eliminate the 3 after that. So we do our subtraction. We get 6 minus 6 is 0, and then we bring down our 3. So now our only thing left is this 3, so we want to do our division step. So we just brought down the 3, that was our last step of the last round. Now we're starting our new round, so we want to do division. We want to do 3 divided by 3, which we've already done, and we know it's 1. So we can put that on top, and now we want to multiply. Instead of drawing a big rainbow, I'll just use my fingers this time. We have 1 times 3, which we're going to put down here, and subtract from our 3. We know 3 minus 3 is 0, and so once we have nothing left like this, we know that whatever is on top is our answer. So 363 divided by 3, if you're doing a long division, it looks something like this, and we get 121. Now, 121. Now what if I asked you to do 364 divided by 3? It would look very, very similar. I almost erased with my finger, guys, don't do that. It would look very, very similar. The only difference would be, in this case, that we're doing 364 divided by 3, so we would change our thing here. And all that would change in this problem is that when we did bring down our 63, we'd bring down a 64. When we did bring down our 3 from here, we'd bring down a 4. And then we still do the same division, so we'd do 4 divided by 3, which gives us 1 point something. We don't really care what this something is, we just want to know the whole number, right? So that's what goes on top, the 1 before the point something. We don't like decimals, okay? So we go 1, if we were doing our division from here, 4 divided by 3 gives us 1. Throw it up here. To our multiplication, we get 3, we subtract 4 from 3, and then this time what we're getting is 1. We have 1 left over. So now what we have left is, if we were to do our first step again, we have 1 divided by 3. 1 divided by 3. And this gives us an icky, it's like equal to 0 point something, right? Which, yeah, so 0 point something. So we only want the whole number, but there is no whole number. So what this means is that this is going to be our remainder. So our answer for 364 divided by 3 is still 121, but we have a remainder of 1. And that's kind of the cheater way to write it. So actually the way we want to write it, and this will be important later when we do our polynomial long division, we want to write it as 121 plus our remainder, so 1, divided by our divisor, which in this case was 3. So we have 121 plus 1/3, and if you don't like writing that plus in there, that's fine. We can make it invisible, right? 121 and 1/3. It's all the same. Sweet, so now that we've done that little review, let's go ahead and get into the polynomial long division. We're gonna start, simpler and work our way up. So we'll see how this goes. So our first one that we want to do is 3p cubed plus 6p squared plus 15p. We want to do all of that divided by 3. So the first thing we want to do is we just want to set this up the same as our other long division problem. So we have 3p cubed plus 6p squared plus 15. We have all of that divided by 3. And so what I don't want you guys to do, and a lot of people get tripped up on this, don't get tripped up by these terms here, this p cubed. We're still going to do the same thing we just did for our long division. We're looking at our first term this time instead of our first digit. We're going to look at our first term. We're going to divide it by our 3 over here. So 3p cubed divided by 3. Well, we know that 3 divided by 3 is 1, so we can change these to 1s. And we're left with p cubed over 1, which is just p cubed. So just like when we did our other long division, we've done our division now, and we want to put this on top as the first part of our answer, which is good. So now we've done our division, we want to do our multiplication. So we do 3 times p cubed. So 3 times p cubed we know is 3p cubed. And we subtract this, they'll cancel, go away, we get 0 left over. So now we've done our subtraction, and then we want to do our last step, which is bring down the rest. Okay, so now we've done our 4 steps, and we still got a couple terms left, so we just got to start all over. So we're going to do our 6p squared divided by 3 this time. I'll come over here, 6p squared divided by 3. We know that our 6 divided by 3, we know that that's 2. We can cross these guys out and do 2 over 1, right? Because we know that 2 over 1 is the same as 2. And that leaves us with 2p squared over 1, or just 2p squared. So now we want to put that on top as part of our answer. But an important part to remember here is that this 2p squared that we got from our division is actually positive. There's that invisible plus signs hanging out there. So we want to make sure to include that in our answer. Otherwise, it would just look weird to have p cubed. It would look like a multiplication if we didn't have this sign here. But we don't want to multiply because we're dividing this polynomial with additions. So that's why we have to do that. And we'll have some later that are negative here, and then we'll put a minus up there. But for now, this 2p squared is positive, so we put a positive 2p squared as the next part of our answer. So now we've done our division, we want to do our multiplication. We have 3 times 2p squared, so we know that 3 times 2 is 6. And then we still have that p squared that we're multiplying by, so that guy comes along for the ride. And we subtract this now. We've done our multiplication, we're subtracting now. We know this will just give us 0. So we do our last step, bring down, and we have a positive 15 left over. So just like earlier in this problem and in our other earlier long division, we want to do 15 divided by 3. This one, pretty easy. You could plug it in your calculator if you want, or you can just, do mental math. So we know that 15 divided by 3 is just 5. So that's our next part of our answer. And again, we don't want to forget that this has got a little invisible positive sign out here, so we want to put a plus. Now we do our multiplication. 3 times 5, 15, and we subtract that, and we get 0. So this one was nice and didn't have any remainder. We'll do some later that have remainders, but for now, let's do one more, and we're just going to add a little bit of a wrinkle to it. So let's see. Oh, and our answer after all that work is whatever's left on top, just like with our other long division problems. So now we're going to do the same problem, and the only thing we're going to change, let's see if I can erase this. The only thing we're going to change is we're going to add a term onto this 3. We're going to make it 3p, which means that when we copy it down, this looks a little gross now, but bear with me. So we still have our dividend, 3p cubed plus 6p squared plus 15 divided by, and now we've changed this to 3p, so we have our 3p here. Now, a lot of people get tripped up when they see this term. They feel like they can't divide into this, but we can. So if we do our division step, if we just go along with our steps we've been doing, we have 3p cubed, which I'm going to write as 3 times p times p times p, because we know that p cubed is p times p times p, right? So that's okay, we can write it like that. And then we're dividing it by 3p. So the first part I like to do when I have a problem like this, or a division like this, is do the numbers. So I know that 3 divided by 3 is 1, so I can do 1 over 1. Now we have p times p times p divided by p. So what's going to happen is we're going to cancel 1p on the top and the bottom. what that leaves us with is p times p on top over 1, which is just p squared. So we've done our division now. It was a little more complicated, but still the same step. So we divided, and now we left with this p squared. So we're going to put that as the first part of our answer. I bet you guys can guess what we're going to do next. We're going to multiply these two together. We're going to have 3p times p squared, which gives us 3p cubed, like we wanted. We're going to subtract that, our next step. And sometimes I put this long subtraction line here just to remind me to bring down these guys later. But you guys don't have to do that. So these cancel, we get 0. We did our subtraction. Now we're going to bring down whatever's left over, 6p squared plus 15. And now we're just going to look at our next term, 6p squared, and we're going to divide it by our 3p. So I'm going to bring it over here. I'm going to write it as 6 times p, just because it's easier for me to see the division with these terms like this when I write it all the way out. And you guys don't have to do that if you don't want to. But so I know that 6 divided by 3 is 2, so I'm going to write that as 2 over 1. And then now I have a p times p over p, or divided by a single p. So just like the one above, we're going to cancel 1p on the top and the bottom. So what we're left with is 2p over 1, which is just 2p. So now we're going to put that on top as the next part of our answer. And again, we don't want to forget that this is a positive 2p, so we want to put that positive there. Awesome. So now we multiply, we get 3p times 2p. 3 times 2 is 6, and then p times p is p squared. So now we're subtracting that. We have 6p squared minus 6p squared gives us 0. We drop down this 15, and we got 15 left over. Positive 15 if you want to put that, you don't have to. So now, but you guys could guess, we're going to take this and divide it by our 3. Oh, you know what? Guys, I messed up. I wanted to change this problem one other way. I wanted this to have a p over here. Okay. Sorry. I know. It's bad. Forgive me. So when we bring this down, it's going to be 15p, and we're going to be 15p. We'd get a remainder if it was just 15, and we're going to work on that later. So for now, we'll just pretend like this p has been here the whole time, okay? It wouldn't affect our problem up to now because we're just now getting to this 15p. So it wouldn't affect our problem, but it would have changed our last problem a little bit, but it still worked that way. So we'll just leave it like this. So now we've changed our problem a little bit. We've got this 15p, we drop it all the way down, 15p. Okay, so 15p divided by 3p. 15p divided by 3p. So 15 divided by 3, we still know it is 5, so I can put 5 over 1. And now we have a p over a p, so those are both going to cancel, and we're just left with 5 over 1. So this is the next part of our answer. We're going to put plus 5, don't forget that positive sign there. And we're going to do some multiplication. 3 times 5 is 15, I know that, and then there's just 1 p hanging out there, so it'll just come along for the ride. We subtract that, and we get 0 left over. So yeah, if we hadn't put this p here, we would have got a remainder, which is gross. We'll do that later. But for now, this way, we have a 15p minus a 15p, which gives us 0. So now our answer for this problem is p squared plus 2p plus 5. Very good. So now we're going to move on to a little more difficult one. And the reason that this one's going to be more difficult is because our divisor, what we are dividing by, our divisor is going to have 2 terms in it. It's going to have 2 bits instead of just like a 3p or a 3. We're going to have a couple things. So the problem we're going to do now is 6x squared plus 9x plus 3, and all of that divided by, let's see, make sure I copy this down right since I messed up the last one, x plus 1. Yep, that's what I got. Okay, so the first thing, don't freak out about this. The first thing we're going to do is just our setup, which is the same for all of these long division problems, right? It's the same when we use just numbers. It's the same when we do polynomials. The way we set this up is the same. So we're saying that this divided by this, which is exactly what we have up here. So what a lot of people want to do is they want to look at this whole thing right here. They want to look at the whole x plus 1 and try and divide it into here. And that's where people get hung up. So what you really want to do is you want to pretend like you're covering up these parts. So like, let's see. So you just have this x and this 6x squared. And we want to look at the first term of our dividend and the first term of our divisor and just divide those. So we're still doing the same steps, just in a little bit of a different order. Or not in a different order, excuse me. It's just a little different because we're going to forget about this 1 for now. So we have 6x squared, divided by x. So we have 6 times x divided by x. We know that one of our x's can cancel, which leaves us with 6x over 1, or just 6x. So we can put this as the first part of our answer. Now, just like the division was a little different, our multiplication is also going to be a little different. And the way it's going to be different is that we're going to multiply this 6x not only by our x, but also by our plus 1. So if we were to go back to our rainbows like we did earlier, we're multiplying it by both these guys. So if we do 6x times x, we have 6x squared. And then if we do 6x times 1, we have a positive 6x. Okay, so our division was a little different, our multiplication was a little different. Now our subtraction is going to be a little different as well. The way you want to do this is once you've done your multiplication and you have this down here copied, you want to put it all in parentheses and then put a subtraction here. And the reason you want to do that is because what people tend to do, they look at this plus 9x and they add 6. So they would get this to cancel, and then they'd have 15x left over. But really what we're doing is we're saying 9x, positive 9x, write it over here. We have positive 9 minus a positive 6. So minus a positive 6, which is the same as just 9 minus 6, which we know is 3. And we know that 3 and 15 are two very different numbers. So we want to make sure that once we've multiplied, we put what we have in parentheses and we subtract the whole thing. So we have 6x squared minus 6x squared. That's still going to go to 0. But now we have this 9 minus a positive 6x like we did here. So we're going to be left with a 3x. And then now we've done our subtraction and we want to bring down the last term, which was our 3. So now, just like the last one, we don't want to look at this 1 yet, we don't want to look at this 3 yet, we just want to look at the first term of whatever's left of our dividend and our divisor. So we're going to go 3x divided by x. So just like the one above, we have 1x on top that can cancel, well, 1x on top and bottom that can cancel, which just gives us 3 over 1, or 3. So we put that as the next part of our answer, and we need to remember that that's a positive 3, so we put a positive there. Now, we're going to multiply this by each term, okay? I know that's a little gross, but we're going to go 3 times x, which is 3x. We're going to go 3 times 1, which is positive 3. So then we do our subtraction. We want to make sure to put this in parentheses and subtract it. So we have 3x minus 3x gives us 0. And we have a positive 3 minus a positive 3, which is also just 0. You don't have to put that plus there. We know that they're canceling. You could just do this if you wanted to. So now that we have nothing left, just with like our original long division problems, nothing left means that we have our answer, which is going to be 6x plus 3 for this guy. So far we've done a few problems and none of them have had a remainder, other than that very first, well, I guess the second long division one that we did, 364 divided by 3. So now I want to show you guys how to do a polynomial long division that has a remainder. So this one, we're going to go 2x squared plus x minus 25, all of that, divided by x plus 4. All right, so first thing we want to do, I just want to write it down in our long division form. So we have that divided by our x plus 4. And just like the last one, we're just looking at the first term of our dividend and our divisor, and we're doing our division step. So we have 2x squared, or 2 times x, divided by x. We have an x that can cancel on the top and bottom. We get 2x over 1, which is just 2x. Now that we've done that, we can throw it on top just like our other ones. And now we do our multiply. We're going to multiply by both of these terms. So we have 2x times x gives us 2x squared. And we have 2x times positive 4 gives us a positive 8x. So now we want to do our subtraction. We put this in parentheses. We subtract it. We have 2x minus 2x, or 2x squared minus 2x squared gives us 0. And we have positive x. Okay, so we have like 1x. And we're subtracting a positive 8x, which is the same as 1x minus 8x. And so we know that that's going to be a negative 7x. Okay, so we have a negative 7x over here. And we've done our subtraction, so now we want to bring down whatever's left over, which is our 25. And now we're just, same thing, we've done all 4 of our steps. We're going to repeat them. So now we want to look at the first term of what's left of our dividend, minus 7x. We're going to divide it by the first term of our divisor. So we go minus, or negative 7x divided by x. All that we can do here is cancel some x's. We get negative 7 over 1, which is just negative 7. So like I said before, when we've done our division, it's important that we put our sign that goes with this. So so far, we've only had positives, or just like little pretend positives, right? And so now we have this negative, and so it's important that we include this negative. And the reason that it's important is because when we do our multiplication, we're multiplying this whole negative 7 by x and then by positive 4. So if we multiplied this x plus 4 by positive 7 instead of a negative 7, it would give us a very different answer, and it would actually be incorrect. So we've done our division, we've got this negative 7, we've put it up here properly, now we're going to do our multiplication. So we have negative 7 times x gives us negative 7x, and then we have negative 7 times a positive 4 negative times a positive gives us a negative, and then we have 7 times 4, which is 28. So now our subtraction, we haven't had negatives yet, but we're going to do it the same way. We're going to put this in parentheses, and we're going to put this subtraction sign out here. So the way this works now, people tend to get tripped up on this. They see all these negative signs, and they get tripped up. So what this is negative 7x. We know that. I'm going to do it over here, negative 7x. And we are subtracting, okay, that's what this is. We're subtracting, and we're subtracting a negative 7x. So hopefully you guys can see that when we subtract a negative, it's like adding. So we go negative. What we're really doing is negative 7x plus 7x, which when we have a negative 7 plus a 7, that gives us a 0, which is going to cancel just like we want it to. So now we have this negative 25. I'll move it over here. Negative 25 minus negative 28. And just like with our other one, this is actually adding. So we have a negative 25 plus 28. And what that leaves us with is a positive 3. So if we were to just keep going with our steps, what we'd do now is we'd do 3 divided by x. Well, just like when we did 364 divided by 3, and we had our 1 left over, 1 divided by 3 gives us 0. We said it was 0 point something, and we don't like that, so that was our remainder. Well, in the same way, we don't have an x to cancel. We don't have anything to cancel like we did with our other divisions. So what this means is that this 3 is going to become your remainder. So the way we'd write our answer, we have our 2x minus 7 up here. 2x minus 7. So you still write this down from the top, okay, if you're writing your answer down here. And what we do now with our remainder, we look at it and we say, okay, we have a positive 3 left over. So we're going to go plus 3. And I left a little room because we're actually going to put it over our x plus 4. And I'm sure you're like, Mr. McGill, why would we put it over x plus 4? That looks so gross. Well, you're right, it does look gross. But the reason we do it is because just like the answer, so we said that 364 divided by 3 was 121 and 1/3. And our remainder was 1, and we were dividing by 3. So now our answer is 2x minus 7 plus 3 over x plus 4. And the reason that is because 3 was our remainder, and we were dividing by x plus 4, just like 1 was our remainder, and we were dividing by 3. So with polynomial long division problems that have a remainder, this is how we're going to want to write our remainder. And then say we had a negative 3 here, then this would become a negative. We're just putting whatever our remainder is, and then we're putting it over our divisor. There you go, guys. I hope you learned something. Yeah, if you need more practice, I'm going to make a short 10-minute video with a couple different examples, so hop over to that. Otherwise, ask me questions in class. Yeah, talk to you guys later. Have a good day.